Alrighty, and now we're going to begin section 4.2. And 4.2 are just derivative rules for exponential functions. Exponential functions are e to the x, so like we have here, or some number raised to the x degree, x power. Alright, so some varying power. This could be 3 to the x, 4 to the x, 10 to the x, a million to the x, something like that. Okay. The idea too is that these graphs look very, very similar. It's just that you got to remember e is a number. So this is base e and this one's the special one, e to the x, and it's special for many reasons. But for right now, you need to know the rule, not why it's special. And if the function is e to the x, then its derivative is itself. So the derivative of e to the x is e to the x. For b to the x, it's a little bit different because it's not a special. But if you have, say, 3 to the x, then if y equals 3 to the x, then we can say that the derivative, based on this rule, is ln 3 times 3 to the x. It's the natural log of the base times the base to the x. And you can never, ever, ever alter that base, no matter what. This is just some number. If you put it in your calculator, you'll get a decimal. It's some weird little number. You leave it like this. You don't use decimals. You just leave it like that. Okay? So that's it, really, for that section. I'm just going to pull a couple examples again. So I went over some more in class today. You'll see e to the x a lot. You're going to see b to the x, but only occasionally. You're not going to see it quite as much as you see e to the x. Because, I mean, 2 to the x, 3 to the x, those are pretty much the same. E to the x is in between, right? E is 2.71. So e is between 2 and 3. So if you graph those, all three of those on your calculator, 2 to the x, e to the x, and 3 to the x, you would see that the graphs almost look identical. There's just a little bit of, variation between them, meaning spacing, really. So the only thing you have to be careful for here is a lot of times they'll give you, so again, they're occasional, but when you get them, they're not going to make it that simple. So you might get something like f of x equals 1/2 times 4 to the x, let's say. You cannot, again, alter that base. So you can't go dividing 2 into 4 or anything like that. Leave this alone. This is a constant multiple. Pull it out and say I'm taking the derivative with respect to x of 4 to the x. Hey, I know what that derivative is. It's ln 4 times 4 to the x. And leave it like, oops, out of the screen. Leave it like that. Okay? There's things you can do, rules of logarithms, that you can, simplify this a little bit, but it's just not worth it. You don't have to. So just leave it like that and be done with it. Don't mess around with it because you will get into trouble. No trouble. The other type that they like to give you in this type of a situation is maybe like y equals ln 2 times 2 to the x. So again, this is a number, so you're setting it aside and you're taking the derivative of the functional part. And so that's ln 2, right? So I'm just bringing this down. When I take the derivative of this, that's times ln 2 times 2 to the x. And so a lot of times you'll see the answer choice is written as ln 2 squared times 2 to the x in that format. So just keep that in mind. Otherwise, piece of cake. And don't forget that things like e cubed, e squared, e to the pi, those are just numbers. E to the pi, if you put that in your calculator, you're going to get some number. This is not a variable, it's a number, okay? So this derivative is a constant, so it would be 0. Okay? Pi is a number. But if you have something like x to the pi, well, you have x now to a number, so now you're thinking power rule. So that derivative would be pi x to the pi minus 1. Okay? If you had x to the e, let's say, then your derivative would be e times x to the e minus 1. Alright? And that's the end of 4.2. Now I'm going to I think I'm going to take a break at 7:53 p.m. I'm tired, and I'll probably do a video on 4.3 in the morning and get that posted for you. In the meantime, I did post blueberry pancake extra credit worksheet. I thought it was chocolate cookies. I couldn't remember because it's been a long time since I used it. But the chocolate cookies are for when you learn integration. So we'll do chocolate cookie extra credit next semester. But if you want to make blueberry pancakes, you can make the little like dollar-sized ones, and that way you don't have to, make 20 billion pancakes, big pancakes. Just make the dollar-sized one, one pancake for each person, including myself, because remember, I'm the one who's given the extra credit, so I'm the one who I'm the ultimate taste tester. And bring them into class, and you'll get extra credit towards your worst test for the quarter to help boost your grade. Alright, anyway, have a great weekend, and I'll talk to you next week.